Okay, to everybody, today this is the video for the chi-square test for independence or association, and we're going to use association, the chi-square test for association. So we had the chi-square goodness of fit was our first chi-square test. Then we had the chi-square test for homogeneity was our second test, and today is the chi-square test for independence. But before we get in that, I want to talk about a common misconception in the chi-square test for homogeneity. Many studies involve comparing the proportion of success for several treatments. You got the two-sample z-test, and we got the chi-square test for homogeneity. If we only have two proportions, it's going to be a two-sample z-test. But if it's multiple categories, we're going to go chi-square. Now, the mistake is, most people make a mistake in how they interpret the alternative hypothesis. It's not that all of them are different, it's just that at least two of them are different. Some of them can be the same, but it's that, so we don't, the key thing here, I think the easiest way to solve this problem is to not say they are different, just say they are not all equal. Some of the proportions are not equal. Not all, just some of the proportions are not equal. So we say they're all equal or some of them are not equal. And that's for setting up your alternative hypothesis on the chi-square test for homogeneity. As a related note, you should be following along in the textbook the whole way here. This corresponds very closely to what you see in your textbook, so you should be reading along to make sure we're on the same page. So this time we're going to be looking for a relationship between two categorical variables. Right? And the key thing is that they're categorical variables. They're not something they're measured, they're something we put into categories. And so the key here is, instead of looking at different treatments or different samples, we're going to take a single random sample of individuals from a single population and then classify them according to categorical variables. So instead of taking multiple samples of multiple populations, we're going to take one sample from one population and then categorize it after we do the sample. So look at this. A study followed a random sample of 8,474 people with normal blood pressure for about 4 years. All the individuals were free of heart disease at the beginning of the study. Each person took the Spielberger Trait Anger Scale test, which measures how prone a person is to sudden anger. Researchers also recorded whether each individual developed coronary heart disease. This included people who have heart attacks and those who needed medical treatment for heart disease. And here's a two-way table that summarizes the data. The key is we made a single sample. We didn't have people who were angry and people who weren't angry. We sampled them, and then afterwards we divided them into these categories. So the question that we're going to ask is there an association between anger and heart disease, coronary heart disease. And so if there was no difference, then these proportions should all be the same in each one of these. And they're not. If you look, we go from 1.7 to 2.3 to 4.2. And if we look at that data, right, you will see that there definitely appears to be a pattern. As you get angrier, you're much more likely to get coronary heart disease, is what the trend looks like. We can't say that statistically because we haven't performed a test yet. So what test are we going to run? Well, we are going to run the chi-square test for association independence. I'm going to take out the independence thing, and we're just going to call it the chi-square test for association. We're going to use this. Independence, people get confused when they start using independence because they start getting confused with the independence part of their condition, so we're not going to mess with that. So we often gather data from a random sample, so this is what we're talking about. Our null hypothesis is that there is no association, there's no linkage at all between anger level and heart disease in a population of people with normal blood pressure, and there is an association. So our alternative hypothesis is there is an association. There is some kind of linkage between them. And you'll hear about this all the time in the news. It's reported that there's a link between blank and blank. And what they're doing is they're doing this test. And we'll talk about what linkage means a little bit later. So, the conditions for this test are the same as for homogeneity. We have our null hypothesis. There is no association between the two variables, or there is an association. The chi-square is the same, and the degrees of freedom is the same. The only difference is the way the data was collected, and we'll talk about that at the end. So for our example, right, remember to get our expected values, it would be this to get, here, let's do it this way. To get this expected value, we would do this total times this total divided by this total. And that would give me the expected value in green. If I wanted this one, it would be this total times this total divided by the overall total. But once again, we're not going to stress about that so much because the calculator will find our expected values for us. And then we would just do the chi-square numbers for this. So we got to check our conditions. Is it random? Yes, people were randomly selected for the experiment. Large sample size. All expected counts are greater than 5. All right, the lowest expected count is 14. Independence. Did we sample less than 10% of the people? Well, we're sampling without replacement. And so are there 84,000 people without normal heart disease? Well, there's several billion people in the world, so 84,000 seems pretty low. So then we would do our chi-square, and it's just once again observed minus expected divided by expected. You can do the ... here, and you'll get a chi-square of 16.77. There were 2 rows and 3 columns, so 2 minus 1 times 3 minus 1 will give me 2 degrees of freedom. And we're going to get a p-value of 0.000032. So we are going to reject our null hypothesis and say there is statistically significant evidence of the alternative hypothesis. Because the p-value is clearly less than the alpha, we reject the null hypothesis, include that anger level and heart disease are associated in the population with people with normal blood disease. There is an association between the two variables. So does anger cause heart disease? Well, the question was this a study or an experiment? Remember, we didn't affect treatment. We made a single sample and then divided the people up after the sample. So this was an observational study. And an observational study does not show causality. And this is why in the news you always hear there's a linkage between blank and blank. It doesn't mean one causes the other. It just means they're associated in some way. And we'll go into this idea of two variables being associated in much greater depth in the next unit when we start doing looking at the relationship between two quantitative data, which is where we measure stuff and get numbers instead of just categorical data. So both the chi-square test for homogeneity and chi-square tests start off with a two-way table of observed counts. And they calculate the test statistic, degrees of freedom, and p-value in the same way. The questions that these two tests answers are different, however. The chi-square test is whether the distribution for several populations are the same or different. And the association is whether two categorical variables are associated in the same population. The easiest way to tell which test you want to use is look at how the data was collected. If you have multiple, in this you're going to have to read the problem because it's not going to be apparent in the two-way table. If there is multiple, if they take the sample at multiple different places or times, then that's really multiple samples. And if it's multiple samples, it'll be the chi-square test for homogeneity. On the other hand, if they take a single sample and then divide it equally afterwards, then that's going to be the chi-square test for association. Remember, we're ignoring independence. And so the key thing here is to look at how they collect the data. And we'll be doing several of these tests in class next time. So read the section on this. The test is exactly the same as homogeneity. It's the null hypothesis and the alternative hypothesis are different. And so the question they're asking is different. And you can tell they're different by the way you collect the data. So that's it, and I'll see everybody in class. By the way, not next class, but the class after that, we'll be taking the test on this unit.